Hello everyone, we are Team 23. My name is Paul Lee. Today we are going to introduce our GAN machine robot by implementing our scheduling algorithm. And here's the outline. We have one machine and the customers which consist of two priorities will arrive at the machine at a random time. And our goal is to facilitate scheduling to optimize the expected output.
This is Chao Zhong speaking. Next part is scheduling algorithm. We have 5 rules in our schedule. First, queue priority 0 and queue priority 1. Second, reorder by remained time. Longest remained time go first. 3. Go queue 0 before queue 1. 4. For queue 0's players, playing time equals remained time. For queue 1's players, playing time equals allowed time. Let's assume we have 7 players and they have their own priority, arrive time, and playing time. Player 0 and to player 5 will arrive the queue at time 0, and the player 6 will arrive the queue at time 60. As I mentioned before, we have 2 queues, Q0 and Q1, and they will reorder by their remained time, which is also the playing time. The longest playing time go first. When the time arrives at 50, player 5 and player 0 finish their playing, and it is the time for player 3. Because we don't have any players in our Q0, so player 4 will be the next player. Now, time is at 60. It is the time for player 4. And at the same time, player 6 arrives the Q0. So after an allowed time, the computer will recheck if any player in Q0. If yes, it will replace the player who from Q1. So player 4 will go back to Q1 and reduce the playing time. Thank you.
Run this session, we made a comparison between our scheduler and the database scheduler to evaluate the performance of our algorithm. And in this evaluation, these are the 4 indicators here. Now let's have a look about the performance. For the total waiting time, our scheduler performance better than the baseline scheduler. In dataset 4, there's the only difference here. The reason of that is there has more high priority customers than other dataset. And also our algorithm is to satisfy the high priority customers as first. So the regular priority customer may wait longer times. And the same reason impacts on the longest response here. You can see our scheduler performance much slower than the baseline scheduler. And also in dataset 4, there has the longest time, and which also improves that dataset 4 may has the most high priority customers in these 5 datasets. And the good thing is that our scheduler has a lower average level than database line in switches. It's around 35% down. And furthermore, there is a tremendous margin in waiting time for 2 priorities customers. You can clearly see the margin here, and especially in dataset 3, a customer in dataset 3 can save over 80% waiting time than a regular priority customers. And this performance doesn't match the evaluation indicators perfectly, but this really matched our expectation. Thank you.
In conclude, in the algorithm we implemented, the priority one's waiting time is too long for the most of data sets, so the longest response time is also very long. We think we could use round-robin algorithm to test which value is better to balance the priorities 1 and 0's waiting time to avoid the longer priorities 1's waiting time. In the future algorithm, the algorithm should be optimized better by decreasing the longest response time. Thank you.